In this video, we'll be looking at a problem based on probability, and this problem involves a little critical thinking. In a stack of cards, there are 5 cards numbered as 11, 3 cards numbered as 12, and 7 cards numbered as 13. 3 cards are taken consecutively from the stack without any replacement. Find the probability that the product of the numbers of the first 2 cards picked from the stack is odd, and the product of the numbers on the second and third card is even. Okay, so I'll explain the question. There are a stack of cards, and in that stack, 5 of them are numbered as 11, 3 are numbered as 12, and 7 cards are numbered as 13. So we are taking 3 cards consecutively without any replacement. Now, if this term without any replacement comes in any problem in probability, it means only one thing. It means that the total number of cards, the total number of the items decreases. Like, let's just say I'm taking one card, and initially there will be 15. 5 plus 3 plus 7, 15 cards. So when I'm taking this card, the total will be 15 out of 15. But when I'm taking the second card, I'm not replacing the first card, so the total would be only 14. And likewise, for the third time, the total would have become 13. So it just means that the total decreases each time, and so the order of the cards that are taken really matters. Okay, so I'm taking out 3 cards. Now, the question wants you to find out the probability that the product of the numbers of the first 2 cards picked up from the stack is odd, and the product of the numbers on the second and third card is even. Which are the first 2 cards that I'm taking? I'm taking out 3 cards without any replacement. The first 2 cards will be these 2. So they want you to find out the probability that the numbers on this card, the number could be 13 or 12 or 11, any number. The numbers on these 2 cards, the product of the numbers on these 2 cards is odd. And the product of the numbers on these first 2 cards is odd, and the second and third card, so second is this card again, and the third card is even. So you have to find out the probability that the first 2 cards is odd and the second 2 cards product is even. So how do we approach this problem? Now, we all know that there are certain rules for multiplication of odd and even numbers. These rules are actually useful for solving any common logical problem in topics like this, like involving numbers. So we know that when an even number is multiplied by an even number, we get an even number. An example for this would be 6 into 6. It gives us 36, and 36 is again an even number. Odd into even is equal to again even number. Example of this would be, let's have 9 and 2. It gives us 18. That is a even number. When do we get an odd number is when we multiply 2 odd numbers. 9 into 3, both of them are odd, and it gives us odd number 27. Okay, so this is something that you have to remember not only for this problem, but any aptitude solving problem on numbers. Okay, so now that we have this, let's look at the options that we have. The first 2 cards product has to be odd. So we can have, for these 2 cards, we can have the option 11 and then 13, right? First I could get 11 and then 13, or I could get 13 and then 11. Now I'm taking these 2 cards with all 3 of these cards without any replacement. So the order actually matters. You have to find separately for 11, 13 and 13, 11. It's 2 different cases. Now let's look at the next condition. The product of the numbers on the second and third card has to be even. So second and third card. So this would be either 11 or 13, right? So for these 2 cards, this is for the first 2 cards. For the second 2 cards, we could have 11 and then 12, because it has to be odd into even. only then I'll get even. It can't be even into even because there's only one even card. That's 12. So the second two has to be odd into even. What about the first two? First two has to be odd into odd. Only then I will get an odd card. Okay. So the first one has to be odd, second one has to be odd, third one has to be even. So over here I could get 11 and then 12 or 13 and 12. This is an odd number, this is an even number. Odd number, even number. Okay, I'll be writing it down in different cases so that you can be more clear. We have case 1. In case 1, I should get an odd number first. We can have 11 first, and then second one also has to be odd. So the second odd number is 13, and then I could have 12. This is one case. Case 2, I could have 13, odd number, and then 11, and then 12. Right? Now there's also another case which most of you would have forgotten. There's a case 3 where I can get 11 and then instead of 13, 11 again and then 12. This will also fulfill the criteria because the first one has to be odd, second one has to be odd, and third one has to be even. In this case, first two are odd. Likewise, I'll have case 4 which is 13, 13 and 12. So I'll have 4 cases totally, and we have to find out the probability for each case. It could be this case or this case or this case or this case. We have 4 cases. So now I'll be erasing all of this to leave some space. So let's look at case 1. In case 1, what happens is I get 11 and then 13 and then 12. So what's the probability of me getting 11? Let's look at the question again. There are 5 11 cards and 3 cards that are 12 and 7 cards that are 13. Okay, so the probability of me and totally there are 15 cards. So the probability of me getting 11 would be 5 by 15 because there are 5 cards that are 11 and then there are totally 15. The next card which I'll pick is 13, and what is the total number of cards? It is picked without any replacement, so the total would be 14. So this would be, there are 7 13 cards, so 7, and then 12, the total decreases again, so it's 13, and the probability of me getting 12 will be 3 by 13. So this will give me 1 by 26. Okay, so now I've gotten case 1. Let's look at case 2. In case 2, I need to get 13 and then 11 and then 12. What's the probability of me getting 13? 7. 11. Probability of me getting 11 would be 5 and 12 would be 3. It will be the same as this one. If you notice, it will be the same 1 by 26. Let's look at case 3. Case 3 will give me 11, 11, 12, right? Probability of me getting 11 would be 5 by 15. 11 again would be. Now here's the difficult part. One card of 11 is already taken out. So how many cards of 11 are left out in the stack? Only 4 cards are left out. So it will be 4 by 14. The total decreases. So does the number of cards that are numbered as 11. it won't be 5 cards, it will be 5 minus 1, 4. Third one would be 12, and 12 would be 3 cards. So we have to find out the answer for this. 1 by 3. This would be 2 by 7. 3 will get cancelled. So we have 2 divided by 13 into 7. I'll calculate this and tell you. This will give you 2 by 91. 1 second, let me double check if I've done it correctly. 5 by 15 into 4 by 14, 3 by 30. Yes, this will give me 2 by 91. Let's look at the fourth case. In the fourth case, the first two are 13 and the third one is 12. 13, 13 again and 12. What is the probability of me getting 13? There are a total of 15 cards and there are 7 cards numbered as 13. Next the total becomes 14 and the number of cards numbered as 13 becomes 6. And then we have 3 12 cards. This will become 3 and 7. So we will have 3 by 5 into 13. And this will give us 3 by 65. Let me just double check if this is correct. Yes, so this will be 3 by 65. Okay, now we have 4 cases. One of it is 1 by 26. The next one is also 1 by 26. Third one is 2 by 91. And then we have 3 by 65. Now what do we do with all of these numbers? If you notice, it depends on whether you multiply it or add it. In which cases do you actually multiply it? You multiply it if it's AND. I've mentioned this in other videos, and you add it if it is OR. In this case, what did I actually do? It could be case 1 or case 2 or case 3 or case 4. It could be this or this or this or this. So what do you have to do? You have to add everything up. So you get 1 by 26 plus 1 by 26 plus 2 by 91 plus 3 by 65. So the answer of this would be the probability that the product of the numbers of the first 2 cards picked up on the stack is odd, product of the numbers of the second and third card is even.